Hello, everyone. Good morning, afternoon, and evening, wherever you are tuning in from. My name is 𝗠𝗏𝗃𝗁𝗍, Community Program Manager at Databricks. And if you're watching this stream right now, you are part of the MLflow Community Meetup, and we're very excited to have you. A big thank you to everyone joining us live, and a special shout out to our speakers, Yuki and Ben from Databricks, and Mikhail from Nebius. Wherever you're tuning in from, we're streaming live right now to YouTube, X, or LinkedIn. You're part of the conversation, and feel free to drop a comment in the chat. Let us know where you're tuning in from and any questions you have throughout today's presentations. Let's get started here. For everyone tuning in today, I just want to give a special shout out to Data and AI Summit, which Databricks will be hosting June 9th to the 12th in San Francisco. We're offering 50% off your Data and AI Summit ticket. That's huge savings. So drop a comment and we will send you a message with the exclusive promo code. Okay, let's quickly run through today's agenda. First, we'll cover how to get involved with the MLflow community. Then we'll dive into today's presentations, MLflow 3 migration for OSS users with Yuki and Ben, followed by Master Agentic AI development with Managed MLflow with Mikhail. After each talk, we will be doing a live Q&A, so keep your questions coming in the chat. If we're unable to address them during the presentation, we will circle back to them at the end of today's session. So, all right, let's get started. I'm happy to hand things over to Yuki and Ben to walk us through MLflow 3 migration for OSS users. Take it away.
Sure. Could you go to the next slide? Oh, maybe I should. Okay. Yep. So hi, folks. I'm Yuki. I'm a software engineer at Databricks and full-time maintainer for MLflow for 1.5 years. And also, here's a Ben.
Yeah, I'm also an MLflow maintainer. Work with Yuki every day. It's an absolute delight to get to work with him and the rest of the team that supports MLflow.
Cool. So, yep, it takes a bit of time to load the next. All right. Yep. Today we're going to talk about MLflow migration. The talk will be a bit short and quick. We'll just cover a brief overview of what will change in MLflow and what kind of how you prepare for that. We are still in preview mode, and we'll be stable in 1 month or so. So what should we prepare? And then after maybe 10 minutes, I'll hand off to the Mikhail, the great demo for the agentic workflow. All right. So we've been talking about MLflow 3 quite a few times, but what's coming in MLflow 3? So here's a few big rocks in MLflow 3. We have a lot of features, but the most biggest one is model-centric architecture, which I will showcase in the next slide. But basically, we are changing the fundamental data model of MLflow to model-centric so that you can manage your models and other metrics or artifacts or many things in your experiment in with very strong lineage. And also, there's a new evaluation coming for LLM and Gen AI. MLflow 2 already has a LLM evaluation feature, but it was designed 2 years ago, and there's a lot of things changed. So we kind of fine-tuned the APIs and set up components and UI to streamline the evaluation for LLM more. And so, yeah, and also there's that feedback tracking. If you're working on never a machine learning project, where you have a data set and you want to annotate things, you want to give feedback on the model's output. So we will provide a your capability to track those feedbacks and the data sets so you can manage your evaluation cycle well. And last but not least, there's a huge UI overhaul available in MLflow 3. So yeah, the current UI being, I think it's been 4 years or 5 years around there. So we are doing a lot of modernization and update on the UI, so you can so you can navigate and also organize your artifacts pretty easily. And yeah, there's a few, quite a few more new features which we don't cover fully yet, but will be disclosed in the Data and AI Summit. All right. So let's take a look at what model-centric architecture is in a concrete code example. So here's an example of logging a model. So in MLflow, the logging model is a very basic thing you want to do. And in MLflow 2.x, when you log a model, you always need a run. So you start a run doing the with MLflow start run, and under that run, you call the log model to basically log model to that run. And the reason you need to do that in MLflow 2 is that model is actually not a standalone object. It's actually an artifact of run. So it's basically outputs from run. So you log a model as output from run. So every time you access to the model or you refer to the model, it actually need to go through run. So your model ID looks like a run / blah blah. But in GenAI particularly, you don't have a strong reason to have a run. So for example, if you're using a scikit-learn, you start with the model training, which is run. So it's very natural to store a model in a run. But if you're doing GenAI, for example, LangChain, you don't have to do training. So you just start a run just for the sake of saving model, which is not great. So in MLflow 3 world, we get rid of the paper cards, and now we introduce a model as a first citizen object, which means that if you create the model, if you want to log a model, you just call log model in the right side, and you will get a model ID which starts from model.blah/. And of course, you can still create a run and do a log model under that, but your model will be a standalone object associated with the run. All right, and yeah, we get a perfect question at the time, very perfect time, but next time we talk about evaluation and traces. So in MLflow 2.x, when you want to so we have MLflow.evaluate API, and when you want to associate that result to a model, the only way to do that is associating them, creating them under the same run. So you start a run with MLflow.MLflow start run, and you call the log model first, and then you run the evaluation to basically couple them together in a run umbrella. But yeah, this is also not very convenient because typically you don't actually run the model training, model saving and evaluation at the same time. You want to run evaluation after creating a model, or you want to run evaluation multiple times, or so in this case, this run-based logging is not very convenient. So in MLflow 3 world, we have a model as a standard alone object. You have a model and you have ID of the model. So when you call the MLflow.evaluate, you can just pass the model and model with a URI or model. Then MLflow automatically associates the result from the evaluation, for example, the metrics, to the model. So when you open up the model in the UI, you will see the list of evaluation results that the MLflow produces, and also you see the metrics for the model, and you can compare between the models. This is very convenient way to maintain the evaluation result associating with each model version. All right, so next is, sorry, it's loading. Yep. So next is traces. So similar to evaluation results, the way you organize traces for model. So if you have a model, and if you, let's say, 𝗠𝗟𝗃𝗃 model, and if you run the 𝗠𝗟𝗃 MLflow 𝗠𝗟𝗃 log, every prediction produces traces, but you want to organize them into a different bucket, different model version, so you can review it or query it easily. But the only way to do that is starting a run in the 𝗠𝗏𝗃. So as you can see in the left side, not only way, but you can start with MLflow start run and predict under that context manager to associate those traces to run. That is one way. And the other way is adding a tag. So you can set the trace tag, a tag on the trace, which has a model version name or any reference name you want to pass as a tag value. But both way is not very ideal. It's more like, because yeah, imagine you have some production system. You don't want to start run every time you make a prediction. And so tag is okay, but tag is like this kind of annotation level. So it doesn't work very nicely if you log a model. So you can log a name of the model as a tag, but they are not linked together. But in MLflow world, you can just associate model traces to model with just one call. So it's called a MLflow.setActiveModel and pass a model name. Sorry, this needs to be a keyword argument, but anyway. So if you call this API, it's similar to active experiment. So this model name becomes active state in the process, such that MLflow can lead and associate any artifacts, for example, traces or evaluation or runs to that model ID. So in this case, if you call this setActiveModel and then call graph invoke, then these traces are automatically associated with this model ID. So this is pretty convenient too. And yeah, if you go to model tab, there's a model page. There's a tab called traces. From there, you can see the list of traces associated with that specific model. All right, so this is a brief overview of what is changing because of this model architecture. There's a few more minor changes or a few more new APIs, but we don't cover everything in this session. We will have so the question is, when should you start migration? So currently, MLflow 3 is in a kind of beta mode, preview mode. So we publish a few release candidates to 𝗶𝗶, and we can install it by pip install MLflow/play. But since it is still in preview, API may slightly change before the stable release. So if you have a production workload with MLflow, we recommend you to migrate after stable release. And the full migration guide, including the examples I showcased before, and also other APIs or any other more complete tutorials will be available at the stable release time. And the stable release will be around Data.NET Summit, so it's coming in the 3 weeks or so. So before that, we still highly recommend you to try it out and play around with new APIs, but still recommend production migration after stable release. Yep, and when you do the migration, please make sure your client and server are both upgraded, because if your client is on if your client is 2.x and if your server is 3.x, that causes some problem. So if we have a migration script to upgrade your tracking server to 3.x data model, and you can still see the existing models or existing traces recorded in 2.x in a 3.x server. But the one caveat is, once you upgrade it to MLflow 3 and you log the model or traces in 3, you can't read these from 2.x client. So once you upgrade the server to MLflow 3, make sure your client on notebook or anyone in your team is also updating client to 3.x. Yep. So last year I just brief covered the new features and other than the model-centric IA in MLflow 3. So yeah, the first one, yeah, as we talked, the new LM general evaluation. So the image is a bit too small, but basically we were adding the new set of APIs and UIs for evaluating and monitoring LLM general application easier with various metrics. So you can use the built-in metrics. You can use you can define a custom metrics, or you can use 3P great evaluation libraries like Lagas, Deep Check, or anything. And you can just see some nice UI or UI to compare results or dive deep into each answers to recall the bad quality or blah blah. So this would be the completely new experience for you if you're doing LLM evaluation. And the second work is dataset feedback tracking. So yeah, as we say, we provide a new capability to track feedbacks or ground truth for your data and manage it as a dataset, so you can use it for evaluation or even training. And lastly, yeah, UI modernization. We didn't put the UI in this precise slide yet. We will show this in the Data Summit. But yeah, we overhaul the UI, reorganize the components, and modernize things to allow easier navigation in your experiment. Cool. So yeah, that's a guest of the MLflow 3, but just stay tuned to the Data and AI Summit. It will be June 9th to 12th. And there's both offline and online tickets. So, and I think online one, you can actually see some sessions by free. And yeah, I searched on the session list yesterday and found out 94 MLflow related sessions, which is a huge number. Yeah, it's very hard to watch all of sessions, but I will recommend you to watch the MLflow 3.0 session here, which will be done by one of our very cool colleague. But this will cover other new features of MLflow 3 and also some special features in Databricks. So yeah, that's all from my part. And yep, we're gonna do a QA here, right?
Awesome. Great. Thanks so much, Yuki and Ben. We have a few questions here regarding this topic. First, what are the main motivations behind the shift to a model-centric architecture in MLflow 3? And how does this benefit open source users compared to previous versions?
Main motivation, boredom. I don't know. We wanted something to do. No, what we wanted to do was look at the pain points. It was originally mostly focused on Gen AI, like the fact that we're shoehorning in a bunch of development workflows that are designed for traditional ML into the Gen AI workspace. It just didn't work, right? So there was effectively a lot of workarounds that had to be done in MLflow 2 to make that experience not totally broken. But when looking at it holistically and saying what should be built here to support this workflow, shifting to something where in the Gen AI world, you have a lot of additional information that needs to be attached to your application. It's not really a model. It's like, hey, I'm pushing out an application code that happens to talk to models and use tools and all sorts of things. And as Yuki mentioned, traces, evaluations, feedback, annotations, monitoring of these things in real time. All of those things need to attach to that original version of your application code. And the only way to do that in a salient way was to move to this model first idea and make sure that we can attach all of that additional ancillary metadata regardless of where it's generated. Some of that stuff like traces are generated in a serving system at deployment time. They have nothing to do with like your local development flow in MLflow when you're like logging stuff. So that supports all of that. And some of the other key critical features that will be coming in the next 6 months to 1 year it'll become even more apparent why we did this now, to make it be like, okay, now we can really use all this stuff and we can track lineage and we can see wherever a model is being consumed, we can track it back to the source that actually generated it.
Perfect. Thanks for that context. Can you also explain how associating evaluations and traces directly to models simplifies experiment tracking and management in MLflow 3?
Speaking from the perspective of somebody who's never built a production one, but has done a bunch of demos of probably overboard levels of complexity in some meetups and talks, trying to do like work on something that isn't a hello world example, that's a little bit nerdy and has a lot of information associated with it, like code complexity and what I'm trying to do. Not having that ability to link things is an absolute nightmare. To try to figure out like, okay, I've iterated 30 times on this thing, and I think number 11 was the one I wanted to go with, but what I now have to add all these tags to all of this data. Then I have to search for the stuff and try to like reconcile what were the traces that were associated with this one? What was the evaluation that I did that made me think that number 11 was the best out of 30 iterations that I tried? It was a horror show. So having those associations allows you to just go directly in the UI. I can go click on that model and I can get all my traces associated with it. Even after I deploy it, I can see all my production traces associated with it of stuff I was doing for testing. I even can get things that I did live during a demo associated with that. So I can go back later on and be like, oh yeah, I asked this really stupid question in the demo and I could see the answer. So it enables you not just to streamline your development workflow, but also think about what it means when you deploy this. Being able to get that visibility into the performance of what you're deploying is super critical. And it'll save you not just, oh, this will save me a couple of minutes of doing something. It's like, no, you can measure this in person days of effort for something that's actually deployed into production.
Yeah. Also, I think one point about evaluation is that if you're in the run world, you cannot associate run to run unless you're using the like nested run things. So that means that if you create a model as a run, if you have evaluation, they just need to be in the same run. So if you run evaluation multiple times, which means that all of these artifacts need to be in a single run. And this will be a giant, very dirty run that contains all the evaluation artifacts, overriding the metrics. So, and when you have a model, you can actually achieve that one-to-n mapping of model and run. And you can see the list of evaluation you've done in the model without overriding metrics, complicating a single run. So which is a very correct way to model the relationship between model and evaluation. So
yeah, definitely. And also code cleanliness with respect to modules. Like having the logging as well as evaluation in a single like script is just a nightmare for maintenance. Like, okay, I need to run another evaluation run. I have to update my source code that logged the model in the first place. It's just really weird. And most people have those separated out into different files. And this supports that.
Great. Awesome. Following up here with another question, is there anything specific components or APIs in MLflow 2x that have been deprecated and or replaced in MLflow 3?
Oh yeah. As Yuki had alluded to, evaluate, which was a pretty big source of between the two of us, he and I remember when we first talked about it like a year ago. We're like, hey, why is this API so hard? And why are we so afraid to touch this code? Because it was basically took the Gen AI functionality and baked it into the pre-existing classic ML and deep learning evaluation, which made the API super complex. And the internal logic within that was so scary to do any sort of manipulation to, just unpacking that. I'm sure Yuki could talk for a couple hours about how unpleasant it was unpacking all of that logic into a separate module, but it wasn't what we wanted, and it wasn't good for users. So that is a breaking change, but it's a breaking change for the better. So the new APIs are very clean, including the improvement that you did this morning. It was awesome. Great PR. But making this so it's just more usable and easy to mess around with. There's also a list, and we're going to maintain it within our docs for the MLflow 3 migration of previously marked as deprecated APIs that have been just fully removed in MLflow 3. They have very low usage. They had problems with them. We knew that there was a better replacement for them, and that usually was in the deprecation message. So those will be removed. There are a few integrations that we're getting rid of due to extreme low usage, and the fact that the library that we were integrating with is effectively no longer maintained. So we can't do things like support modern infrastructure. One that comes to mind, MLeap, right? MLeap was the greatest little tool for deploying a Spark ML model in the open source community. Unfortunately, that project basically is no longer maintained. So for people that are migrating to Spark 4, you won't be able to use that. So any model that's created in there, MLeap doesn't support it, so you can't deploy that. So we're moving towards just more fully supporting Onyx as a replacement for that. But definitely check out the docs page that lists out all of that stuff.
Perfect. We'll put a link to the docs in the chat, wherever you're tuning in from. The last question here, and then we're going to transition over to our final presentation. How does MLflow 3's model-centric architecture work with Gen AI model providers, where the model is really just an API call with no associated artifacts?
That's a great question that kind of feels like it's alluding to something. So I'll answer what I think the actual root question is. The model in Gen AI is basically just a wrapper around a REST call, effectively, or a series of REST calls. It's an application. So one thing that is actually changing with MLflow 3's approach to serialization of artifacts associated with Gen AI is we're no longer even going to try to do that. It's a horror show to try to maintain serialization and deserialization capabilities for integrated libraries. You look at LangChain, Llama Index, you name the authoring library that's out there. In MLflow 2, we had limited support for certain types of serialization, but all of the new cutting edge things that are coming out, they all have references to singletons. They all have external references to that object that we're trying to serialize. You can't pickle that. It doesn't have the reference, it can't capture all the references correctly. So we just wouldn't support that. So people would try to do it, and then we'd get a comment on the issues page saying, hey, this isn't supported. And we're like, yeah, we know. We can't actually serialize that. So coming in MLflow 3 is models from code as a first class way of basically capturing state. There's other features that I'm not going to talk about right now that we're going to be doing in the future to make that even more robust and simplify that process. But for now, basically log your script that defines your code as your application, and we'll handle that for anything you want to do with Gen AI.
Yeah. Also, actually, you don't even have to log your models, your code sometimes. You just want to create a model. You store the code in your GitHub, or you store the code in somewhere else, or you don't even have a code. Yeah, as your example, like just call the Gen AI provider. In the case MLflow, we create an API to just create a model without anything, like empty box. So you can associate things to that. So that is this model provider thing is exactly the one example we kind of thinking about model-centric architecture. Because if you have a run architecture, you don't have a way to refer to this kind of, I would say, wrapper model in a run. So you can create a model as an empty box in MLflow 3. You can associate metadata, traces, params, or Git repository, or whatever. So it's pretty flexible. Actually, you can use for various range of Gen AI applications.
Excellent. That is all the questions that we have right now in the chat. If you have any more for Yuki and Ben, feel free to drop them in and we can address them later. Or of course, join us on the MLflow user Slack. All right, now we will transition over to Mikhail. Welcome back to the stage.
Yeah. Hi, everyone. So happy to be here. Yes, thank you for inviting me. Yeah.
Awesome. We are
And
thrilled to have you. I'm going to give you the stage now, and if you need anything, just let me know.
thank you. Yeah, sure. So today we are going to talk still about MLflow 2, and I'm very curious in the upcoming updates on MLflow because it's the great tool, one of the best open source tools and very popular tools. So and I'm happy that your guys improving a lot and moving to this Gen AI stuff. Today we'll talk about a little bit about agentic AI with Managed MLflow, right? But all this content is applicable to open source versions, of course, and we'll see how they'll change after MLflow 3 release. But more or less, it's just a general approach with some basic functionality applied to this agentic AI development stuff. So let me first introduce, before I introduce myself, I want to ask just a question to you to have some context about your work and your interests. So what are your biggest headaches with AI agents? I assume that people who joined this session today are working on AI agents, including AI agents, right? So, and if you do, so please share what are your headaches and issues with AI agents, and maybe like we'll try to figure out how MLflow can help for those issues. So, yeah, just let's do it in asynchronous way. I'll move forward, and if you'll share some of your headaches, I'll come back and we'll discuss them. Okay, so let's go on. Let me introduce myself a little bit and the company I'm working on. So I represent Nebius Cloud. So we are cloud for AI innovators. We provide GPUs and tools for AI development, starting from model training and model fine-tuning to using AI in different AI applications, agents, racks. So like everything you need to develop AI systems, we can provide it. So we are working on this, and I'm a technical product manager, and I'm responsible on tools for AI developers and AI platform, and MLflow, one of service that we provide as a managed service. So my colleague Maria, she's working on MLflow but couldn't join this session, but yeah, so we are working like together. So and we prepare this materials together. That's why she's also with us here on slides. And just a couple of words about like Managed MLflow, why it's managed, because when you work in a small team or you are just a freelancer, so open source version is great. So it's more than enough for many tasks. But when you start to scale up the work and you work in a team, you need to manage it. You need to set up infrastructure. You need to ensure that everything works fine and do the security and backup stuff, etc., etc. And this is exactly how when MLflow managed MLflow can help with, because like in, for example, at Nebius, it's just one click to start MLflow server, and you can start working with it. So it's pretty simple. So, and in terms of use cases and scenarios for Managed MLflow, of course, we see like three main groups of clients and use cases: it's fine-tuning experiments management, it's model and prompt management, and evaluation observability. All these components are applicable to agentic AI as well, and we'll like cover them a little bit during today's presentation. Okay, let's back to the topic, and I just I see a couple of questions. So I asked about headaches that you have during the agentic AI development. So one headache, as I see in the chat, is unpredictability at scale. So yes, totally makes sense. And another. Okay, so another question. So let's give questions to the end of the presentation. Okay, so let's go on to the demo, and I'll show a little bit of Managed MLflow at Nebius, a bit Nebius, and just guide you through the scenario. So why it's important? Why it's important to why it's important, how useful the MLflow for agents development. So first, agentic AI and agents are much more complicated than just a simple web service that are running in the classical ML model. So there are a lot of hidden business logic under the agents implementation, and it could be a lot of LLM calls. So it's like pretty complex systems, and these systems might have non-deterministic behavior. And when you try to build something and then figure out how to reproduce the behavior, right? So something can go wrong, and it's pretty difficult to debug and understand how you get the results that you get, and why it's the result is not what you expected. And actually, it's pretty difficult. They're similar to just LLM evaluation. It's pretty difficult to evaluate behavior of agents, because they are based on LLM calls, and you need usually not. You need some metrics that to measure like some stuff that might have some subjective measurements or evaluation. So it's not. So you need to find some good metrics that you can use. So and of course, like all this stuff like related to different aspects in your projects, including prompt versioning, reusable code, and reusability, sorry, of these agents between projects, etc., etc. So let's dive into the some workflow that we'll discuss today. So imagine that we want to design an agent that can help us to look through like interesting and new AI tools that can like contribute into our project. So we are building something, and we want to find new tools that we can incorporate in our project, and and do something good. So and we will build an agent that can monitor new tools, and then prepare a report for us, trying to compare different tools specifically for our technological stack. So how we will do it? So we'll just build the first version of an AI agent with a 𝗏𝗏 library. Then we'll try to run it and see the results, and then figure out how we can improve it, and see how MLflow actually will simplify this process. So and just highlight main capabilities of MLflow for these tests. And like our final goal is to have the system that can trace all, let's say, log and trace everything about our agent work, so that we can easily to just deep dive into the agent behavior, figure it out how it works, how to improve performance, and actually manage, be able to improve the agent itself based on some objective metrics. So this is our goal for today. So let me just briefly show like the Nebius Managed MLflow Nebius. So if you want to try it, so here in the side menu we have the Managed MLflow, so you can create cluster, and of course I have already cluster created here, and here in this cluster we have like for example, monitoring and logs out of the box, so you can easily like see what's going on in your cluster, and yeah, and we have backups for metadata database that MLflow used, and yeah, so pretty simple to start, and as a result, you have just MLflow that you like, and you can use it. So let me jump into the our code example. We'll share the link to GitHub repository where you could find this code if you like. And let's start with the scenario, right? So to start work with the MLflow that you created at Nebius, so you need to, actually with any MLflow, you need to provide some environment variables like tracking server parse, pass, URI, and some other. So for MLflow, we also provide that certificate parse, like some credentials, and for some of our tasks, like later, we also use Nebius Studio, Nebius AI Studio. And if you like never heard about Nebius AI Studio, this is our like project for serving for inferencing and fine-tuning LM models, open source models. So you can find a bunch of models that you just play with using APIs. Yeah, and we use models hosted by AI Studio just to evaluate our agent at the last step. So yeah, if you well decided to try it by yourself, so just know that this is a APIs that provided by Nebius AI Studio. So how we start, right? Let's just so we set up environment variables, right? And then we start with just with code. So I use CrewUI here to build this agent, and it's pretty simple. It's pretty simple. For this agent, actually, I wanted to use two agents. One is a researcher who is responsible to discover like new tools on internet for my specific project. And I also want to have the specific task that I'm looking the tools for. And the second agent is responsible for analysis and preparing some reports that I can easily read and understand. So also we need to define tasks that our agent will complete for like for this system. I want to have three tasks: search tools on internet for AI stack that I have already in my project. Okay, so it seems, yeah, I forgot to share the screen, guys. Sorry for that. So can you see my screen now? Okay, cool. So we defined that agent with 𝗠𝗏𝗏, as I mentioned. Then we define the search tools that we want our agent to use. It's tools for searching, for analyzing this data, right, and to create the report. At the end, I want to have the report in Markdown format with like nice structure that will help me easily to compare the tools that's suggested by agents. So this is our goal. So we did it, and so it just like requires like some additional class that will define that how which agent will like complete which tasks, and we are ready to start our agent crew to do this job for us. Okay, if we run it, this code, so we will see that there are a lot of logs about like execution steps here, and like I really like the logs provided by 𝗠𝗏𝗏, but the problem is when our agentic system like consists of like few agents and few tasks, so there are a lot of logs, and it's pretty difficult actually to track the progress and try to understand what's going on and why, for example, we have this error. Right, so it's not user friendly, at least. But at the end, I still have some reports, some results here, and I see that I see some Postgres, Fast API, and LangChain as recommended tools that make sense. But I want the first problem that we see here, that it's pretty difficult to understand the behavior of the agent itself, our agentic system. And here how the MLflow can easily start helping us just by using autolog method for mlflow.𝗠𝗏𝗏. So we just need to call this method, and we also like set the experiment name to understand where we'll find all our results, and run the crew again. And as soon as we do it, like MLflow will like log everything to our tracking server, and we'll see the results with traces here in the UI, and can navigate inside, right, and see how our like agents complete tasks for searching for tools. We'll see all LLM calls. We'll see that how it works with memory, and actually the C final report here that automatically logged. So it's like magic, I would say. I would say like some time ago, because it's done automatically by just simple command, and this is already like pretty good results. So at least we can track everything in good UI with a like clear outputs. But let's go deeper and think how we can reuse standard tracking metrics and artifacts functionality from MLflow. And of course, we can just use methods to log params, metrics, and artifacts additionally to what automatically logged by autolog method. And here we just want to, just for demonstration, log some parameter, as for example, the name of the task we are trying to complete here. Then the 𝗠𝗏𝗏 also provides some additional metrics about the behavior results of the agents. For example, like number of like total tokens generated, and information about prompts and successful requests, for example. So pretty useful information. And also we can log some the reports that we generated at the end to MLflow, and set some specific tag, for example, to mark that this run is successful or not. And if we do this, so we automatically get these nice metrics, and we can track how many tokens we used. We can even like calculate cost based on these tokens numbers, right? And we see not only status of the MLflow like run itself, but also the status that we defined for our agent. And we see if like the idea there that if the agent provide the final results, final report in Markdown format, so we can set this success status and understand that everything inside was successful, and we can work with this. So yeah, that's it. Pretty and of course this functionality with the nested runs I found pretty useful here. So what we can do the next step. So we right now we have all tracing for agents. We can see metrics and artifacts. So what else can we do with MLflow? What about like evaluating agent output quality, right? So because right now again it's just some Markdown report, and it's pretty wordy. So I'm interested, for example, to understand how like two different calls of this agent and two different reports are different, and which one is better, right? So I have like a few runs, and I should want to understand which report generated at every run with maybe different parameters is actually better. So for this, we can implement, this is where we can use external LLM APIs to implement LLM as a judge method and use some custom metric. I generated this evaluation prompt to track how like complete and relevant the tools that suggested by agent to my project. And yeah, and we just use this evaluation metric to evaluate the final reports and log this metric to MLflow. And what we have now, actually, we can go back here, and we can log. We can see all these metrics here, additional metrics that evaluate quality of our report. So we can like navigate here, and we can visualize in the way that is easier to understand which one is better. So everything nice. What can we do else? We actually like at the next step, as soon as we can track all actions and LLM calls for our agent, as soon as we track all artifacts, metrics, and parameters, so we can be sure that the runs are more or less reliable and reproducible. We added some additional quality metrics that can evaluate the final results. And now the system looks more or less reliable and ready to do real experiments. So, and at this step, we can just start improving our prompts with clear understanding how these prompt changes will affect the final results, the quality of our reports, and we also will be able to track and control other parameters, for example, as costs and total numbers of tokens generated by the agents. So here we can use the new functionality, relatively new functionality for prompt management, and for our new experiments here we can just register new prompts. We can see versions of these prompts, and and this I really like this new functionality for prompt management and prompt versioning. So this makes the experimenting with agents and Gen AI in general very manageable, and this feeling of having control to this system. So that's it. This is the approach that I wanted to share with you. And yeah, so let me stop sharing. And yeah, so that MLflow 2 is still pretty capable tool, and it's maybe a bit hacky, but it's flexible enough to apply to different scenarios, including like Gen AI and agentic AI. And we are waiting for new updates. I'm looking forward to having MLflow 3 with a new functionality as well. So that's it from my side. So please try MLflow at Nebius platform. Please try another applications and share your feedback. Look into this, and thank you very much.
Perfect. Thank you for the excellent presentation. 2 other headaches came through, by the way, in the chat here, one of which is keeping prompts versioned, reusable, and understandable. And
yeah, I guess we covered it. Yeah,
yes. And the other
good.
one, too, that came through, evaluation. It's hard to tell if it's doing a good job unless you manually check outputs.
Oh, yeah. So manually checking outputs, it's pretty annoying, I would say, when you run it a lot of times. That's why this automatic evaluation with custom metrics really helps. And again, thanks to MLflow for this specific functionality for evaluation.
Awesome. And we have a few minutes here. Let's dive into questions. One of which, how does Nebius handle security backups and support for organizations using Managed MLflow in production environments?
So there are just a basic cloud approaches to how to for security and support. So for backups we used managed Postgres to keep metadata about that for MLflow, and it's automatically have backups. So so it's definitely we have these backups, and for support we have a dedicated team who develop the MLflow and on the platform. So if any questions about the system, we have a support channels, we have email channels. For some customers, we have Slack channels. Yes, and it's pretty quick the reaction to any issues that that might happen.
Perfect. And a follow-up question, what made you choose MLflow as your experiment tracking observability platform at Nebius?
This is a good question. First of all, MLOps is the pretty is very popular tool, right? And it's open source. It's flexible enough. It has applications in classical ML as well as Gen AI. So I think that's why. So we see that people use it, people asking for it. It's easy to start, actually. That's why we added it, and it's also has a good community. So we have also another options to track to do experiment management on the cloud, but MLflow is the only solution that we provide as a managed service at this moment.
Excellent. Thank you. And the last question here in chat, what advantages does using MLflow in a managed setting provide over self-hosting?
The main advantage is the speed that you can start to use MLflow in a team and collaborate in a team with all these agents and experiments. Because when you're working with a team with open source version, so you need to set up infrastructure, like be careful about and solve this settings, do these backups and security and all this stuff by yourself with a managed version. So we provided for you automatically out of the box, and you just need to fill like a couple of fields in the console to start actually using it. So the main like it's speed, how you can start, so it's easy to start, and automatically we maintain and support all this infrastructure for you.
Excellent. I think that wraps up all of our questions here, and we are just a little past time. So I think it's a good time for us to wrap up. Let me just switch here. Huge thank you to our speakers, Yuki, Ben, Mikhail, awesome presentations, and thank you to all of us. Thank you to all of you for joining us.
Thank you, 𝗏𝗏𝗏𝗏. Yeah, thank you all.
Awesome. Just final plug, feel free to continue the conversation by joining us on Slack, contribute or follow along on GitHub, subscribe to our Luma page for more event, and follow us on LinkedIn, X, and Blue Sky to just stay connected on the latest MLflow updates. We will have many more updates to come in just a few weeks. So thank you for joining us today, and thank you to our wonderful speakers.
Thank you. Bye.
Thanks all.